In today's video, I'm going to be going over a stack of Eddy Current training manuals. Oh, it's quite the stack. And just talking a little bit about the differences between different types of Eddy Current training manuals. Starting off with, this is a General Dynamics Conveyor division. This book actually was published, this second edition, published in 1979. Yeah, copyrighted in 1979. And this book was used a lot by aerospace, and it covered the fundamentals of eddy current theory. So there was a lot of things about the formation of eddy currents, how electromagnetic induction works. There's some simple impedance graphs and some quizzes and conductivity curves. They might show some, they show a couple tubing examples in here. But again, very fundamental level 1 type of information. Next, we have a book from American Society for Non-Destructive Testing. This is from Personnel Training Publications, ET. So while the first book only covered eddy current testing, this book, used for classroom training, expands a little bit. It goes into not only eddy current, but also the other two, I call them sub-methods, but they're called ET techniques, really. It includes eddy current testing, remote field testing, which is what you use for carbon steel tubing, and finally, ACFM, which stands for alternating current field measurement. So in this book, there's a lot of graphics. It covers everything in the first book that I showed you. But it goes into a lot of depth in all the different methods. It's very technically correct. It's been updated with some color formula, color pictures of, later technologies. It's got pretty modern test instruments in here. Even got something there for doing magnetic flux leakage testing of above ground storage tanks. But again, this is a good training book if you're going to cover all three of the ET techniques. Actually, this book is so good, I'm going to start making it, at least sections of it, mandatory reading for my online training programs, because it's that good. Now, a lot of companies that perform eddy current testing don't necessarily use either one of those books. Why? Because I would say most companies don't do all three. Some do. I mean, some of the bigger companies will, and maybe in the comments somebody will say, hey, our company does them all. Well, that's great. But a lot of companies don't only do one. For example, they might do tube testing, or they might do surface testing on aircraft. So they are better served by having training manuals for their employees that are more geared towards their specific applications. Now, some of you are wondering, what's up with the camo hat? Well, this is for Babcock and Wilcox. That's where I actually started my career in 1989. And I actually spent about 15 years there. And over the years, it started off at Babcock and Wilcox. Then it was Babcock and Wilcox Nuclear Service Company. Then it went to B&W Nuclear Technologies. Then it went to B&W Spice, Special Products and Inspection Services. Then I believe they were bought by Framatome, and then Arriva, and now it's back to Framatome. So a lot of name changes over the years, same bunch of guys. Great guys. All right. And gals. There's a few gals that work there. So here was the first eddy current training manual that I ever had to use. And this is, which one does it say? Framatome Technologies Integrated Nuclear Services. See, I left that name out. But let's take a look at the thickness of this book. What's that, about 1.5 inches? So this covers a lot of the basic, required eddy current theory that their folks need to have so they can properly set up equipment and record data, because that's the job of a level 1. Help the level 2s set up the equipment, and under their supervision, or under the supervision of a level 3, but it's usually you're working with level 2s, under their supervision and guidance, you'll be setting up equipment. A lot of time you'll be on headsets. If you're working in a power plant environment, you might be wearing protective clothing. You might be inside of some kind of a vessel, wearing headsets, listening to the level 2, but you'll be setting up, maintaining equipment. And if you're lucky, after a period of time of lugging equipment around, you'll be able to actually sit down and record some data. So that's exciting times. Now, if you notice on the cover, that should remind you that this is for tubing, because this company, typically, I'd say a bulk of their eddy current work is performing tube testing in nuclear steam generators. So that's why you see the little 180, 60, 40, 20 signals on the front. This is called a Lissajous screen, and these are called Lissajous figures, but eddy current people know these as the flat bottom holes in the ASME calibration standard. Keep in mind, that's only level 1. Next, I've only got 2 books left. No, I got 3. Now, here's a level 2 manual for a different company. You might be asking, well, how come the level 2 manual is so much thinner than the level 1? Well, here's why. With the level 1 manuals, you gotta love your Dunkin' Donuts. Level 1 manuals, you have to learn all of the initial fundamentals of eddy current testing. Electromagnetic induction, generation of eddy currents, properties of eddy currents, material properties, conductivity, permeability, and dimension, all those types of things. But when you get to level 2, you just have to learn some extra stuff. You have to learn a little bit more about test frequency selection, the different operating parameters that you can select and change for your specific test. And it's basically just a little bit more in-depth knowledge of the concepts and fundamentals covered in the level 1 training. Both of the training are 40 hours last time I checked for the classroom portion. Next, we're going to move on to the 2A manual. Now, granted, this is an older manual, but this is from EPRI. Notice the thickness of that one. What's that about? That's about 3 inches. I'd say this is about a 6-pounder. So it passes the weight test. But the title of this one is Eddy Current Testing Data Analysis for Steam Generator Tubing. And this is only in the draft. Maybe the final was even thicker. Now, when you look in the ASME code, section 11, it says if you're going to be doing testing of non-ferrous heat exchanger tubing, it might even say steam generators. But anyway, the rule is you have to have specific training in the analysis of non-ferromagnetic tubing. And the reason that they put that in there is because, when you're doing HVAC work and you're inspecting air conditioner tubing, it's usually not done to ASME code. But when you're working to ASME code, you got to follow a lot of rules. And in the analysis of steam generator tubing, there's a lot of rules and there's a lot of stuff you need to learn. So this book from EPRI goes through, and again, this is probably their first really intense, training material that they had for tubing inspections. But it had to cover, how multi-frequency data evaluation is performed. They talk about the importance of properly detecting and dispositioning flaws and signals, how to use multi-frequency testing. And then they cover, many different types of damage mechanisms, such as wastage, thinning, and tube support plate fretting, outside diameter stress corrosion cracking, PWSCC, which is primary water stress corrosion cracking that happens on the ID side of the tube. And then the book goes into, and the training, how to distinguish non-relevant signals from signals that you care about. So separating probe wobble from the indication from a floss strand straight up? Or how about separating indications from secondary side or OD deposits at the location of a dent, perhaps? So a lot of times you get several things happening at the same location in the tube. And the thing with multi-frequency data evaluation is that there's a lot of information being thrown at you on the Listager screen. And it takes a high degree of training to be able to separate all of those different inputs into something that's meaningful. That's why doing impedance plane multi-frequency data analysis can get a little bit tricky, especially if you don't have the proper training, because you have all these, sort of competing inputs trying to grab your attention, and you have to figure out what the correct answer is. So you learn a lot of different multi-frequency data evaluation tools, and then you also learn the different methods of quantifying degradation. So, a lot of these test instruments, you can set up alarm gates and things like that to alert you to a condition that may be adverse. And, you might have alarms that go off or lights that flash. Those are qualitative indicators. But if you want to provide quantitative information to your client, such as how deep an indication is or how long a crack is, you have to learn the proper ways to quantify those. So for sizing, things like outside diameter pitting, you might use a phase versus depth curve. For sizing anti-vibration bar wear, you might use a vertical amplitude versus depth curve. For sizing the length of cracks, there's a certain methodology you have to follow. Normalizing voltage, that's an important concept to learn, because if you call up your buddy and say, hey, I found a crack and it's 3 volts, that 3 volts only means something if everybody normalizes their voltage the same way. So we're going to talk about all those standardized sort of methodologies that are used. And that's why it's a thick book. And keep in mind, this is from 1980. So the evolution of this has turned into the QDA program from EPRI. It's a qualified data analyst. So it's just been updated, because this one probably only has bobbin tube testing in it, which is probably the simplest of the 3, techniques underneath eddy current technique. The sub-techniques, I should call them. But the new QDA has RPC, which is rotating probe coil. It used to be MRPC, for motorized pancake, motorized rotating pancake coil. But over time, we didn't just have pancakes. We had plus point coils and axial directed coils, circ directed coils. So everybody was so used to saying MRPC, we just sort of changed it from pancake coil to motorized rotating probe coil. See, so it still fits and we don't have to redo all the books. So it covers MRPC in the QDA and also array probe testing, which, it's not new. Array probe testing has been around for decades, but like anything else, it's improved over time, and it's been gaining a lot of traction, especially like in the last decade, because it's such a time saver, and in many cases, it can increase the probability of detection over bobbin. It also has more dispositioning power than bobbin, and when it comes to resolving indications around the circumference of the tube, because bobbin coil and encircling coils average the whole circumference and give you one signal if there's 3 or 4 at the same axial location in the tube. But array probe, like rotating probes, can resolve indications anywhere around that 360 degrees. So in the case of the ASME calibration tube standard, where you have 4 20s, one every 90 degrees around the circumference, bobbin probe gives you one signal. Array probes will show you that there's actually 4 signals there. And one easy way to tell that is by looking at a terrain plot, and you'll see 4 little peaks. Bobbin data evaluation, you only see one signal. MRPC, rotating probe coils, there you'll also have a terrain plot, so you can see the 4 different peaks from the 4 by 20% flat bottom holes. So the QDA covers bobbin, RPC, array. And then finally, this thin little report from EPRI, which came out in 1980, basically said, hey, there's this thing out there on the streets now called multi-frequency testing of steam generator tubing. And basically, here's how it works, and it does work. So that was a report that was published that people like the NRC review it, and they go, yeah, it looks good. Keep in mind, these are like almost 45 years old, these last two documents that I've showed you. So that just basically lays out the fundamentals of some content of level 1 training, level 2 training, level 2A type training. And, we'll cover the QDA, basics of it in a future video, and you can see which path you would like to go down. Thanks for watching.